Okay, class, allow me to start off with question 10. I thought I should actually go back to question 10 to do it carefully and properly, because I think the last lesson I did in a very sketchy manner. Okay, let's do it carefully. This question, okay, step one for this question, okay? For this question, we first and foremost want to define the function gx. Define a function gx over the interval 0 to 4, x in 0 to 4. All right. So let's sketch this graph to find the range of this function. This graph will look like this: 0 to 4, inclusive of 4 and inclusive of 0. This graph look like this. The maximum point is when x is 2, and when x is 2, the y coordinate is 4. So which means the range of the domain of G, of course we know the domain of G is actually 0, 4, and then the range of G is equals to 0, 4 as well. Alright, then we define another function fx. Okay, the suggestion is to define the function fx okay, as I think that square x will do. No, I think square x will do. Although the suggestion here is modulus x, I don't think you need modulus x. No. I think that square x will do. Right, we then have function fx, and also let the domain of fx to be just from 0 to 4. Alright, now to prove that this function hx, right, is continuous on a closed interval 0 to 4, we have to do two things. Okay, first and foremost, okay, we want to say that hx is made up of f of gx, right? Since g is continuous, okay, since g is continuous, on this number, on 0 to 4, okay, let's use open bracket. Okay, let's do the open bracket first. 0 to 4, and fx is continuous on 0 to 4 also, then hx is continuous on 0 to 4. We used an earlier result, no? Do you remember the earlier result that says if a function is continuous at a point, and then another function f is continuous at the image of the point, then the composition, okay, the composition will also be continuous at the point. Okay, okay. So because G is continuous, f is continuous, so therefore at the point in question, fg of x will also be continuous. So that settles the continuity of hx in the open interval from 0 to 4. Now to talk about the continuity of hx in the closed interval at the end of it, we have to show this. Now we have to show that limit. Now we check the limit as x tends towards 0 plus of hx. We have to show that this thing is equals to h of 0. We also need to show that limit as x goes towards 4 minus of hx is also equals to h4. Okay, how do you do it? No, so this becomes limit as x goes towards 0 plus of f g of x, right? And then because the function f is continuous, this becomes function of limit x goes towards 0 minus of gx. And because g is continuous at 0, this becomes f of g0. And this becomes, okay, g0 is what? G0 is 0, so become f of 0. And f of 0 is actually 0, so indeed is equals to h0. Why is it so? No, because your function hx is defined to be this, right? And h0 is obviously 0 also. Then you got to actually now do it for the other one. When x tends towards 4 minus of f of gx, and this gives you function limit. I bring the limit in because function f is continuous. This is plus, I wrote only. Okay, then gx, and this becomes, okay, because function g is continuous, this becomes g of 4, and g of 4 again is 0, and f0 is also 0, and again this is h of 4. So therefore hx is continuous on the closed interval. So the whole exercise for this question is to actually make you go through continuity of a closed interval by proving that it is first. Yes. Say. Okay. So for this question, you're trying to prove continuity of hx over open interval first. Then after that, checking the endpoints. So this is the aim of this question 10. Alright, so I think that yesterday I think a bit sketchy, so I decided that I should do it properly today. Okay, with this right, let's go on to look at question 11. Okay, question 11. You are given a function is continuous on this interval and on this interval. Okay, so very careful, no. The continuity is over minus 2 is 0 and over 1 and 2. Alright, so now they ask you, know, when can you use IVT to ascertain the accident of roots? So let's check, okay? So here says between minus 1 and between minus 2 and minus 1, let's check, okay? Between minus 2 and minus 1, yes, there's a change of sign, and the function is continuous over this interval, so this is correct. And then between 0 and 1, now between 0 and 1, right? Between 0 and 1, you can't tell, no, because the continuity doesn't span over, doesn't span over 0 and 1. Can you see? This one here and this is 0. So for the reason, we can't be sure, no. This one can't be sure, so we gotta put cross. Then next one is between minus 1 and minus 2 and minus 1 again is true. Between minus 1 and 0, 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 right? Again, there's a change of sign. Right, there's a change of sign, so yes, this is true. Okay, then let's try the part C. Between minus 2 and minus 1. Again, this is true. Between 1 and 2, let's check again. Between 1 and 2, between 1 and 2, right? There's no change of sign, you know. So this can't be true. Between minus 1 and 0, right? Between minus 1 and 0 is true because there's a change of sign. And between 0 and 1, between 0 and 1, now between 0 and 1 can't conclude because I told you, right, there's no continuity between 0 and 1, so I can't conclude. Between minus 2 and minus 1 again is true. Between minus 1 and 0, between minus 1 and 0 is again true. And between 0 and 1, we can't tell. So therefore, based on this selection, my answer therefore is B. Alright, so this is a trick question, no? You want to trick student into believing that just because of change of sign, things will always work. You must check for continuity, you know. So this question tells you that over here there's this continuity. Oh, sorry, there is no known continuity between these two numbers, 0 and 1. So I can't tell. Right, that's question 11. Okay, question 12. Comment um, on the continuity of the following function. So for this one, right, maybe it's good to have a rough sketch of the graph. Okay, so for this graph, right, a rough sketch of the graph will help us, no, to see what kind of a continuity. Typically, class, I want you to know, no, whenever you come across a quadratic function over a linear function, right? Typically, the graph will be either this type of graph, or this type of graph. So a quad over a linear function, right? The graph will be either one or the other. And one way of checking things out is you might want to say do a long division of this function, you know. You do a long division of this function, you know. So x squared minus plus 0x minus 2. So there's going to be 2x minus 3. So you perform long division, the first number you will need here is actually half x. So then become x squared minus 3 over 2x. 3 over 2x minus 2. Then you need a plus 3 over 4. So this one 3 over 2x minus 9 over 4. So this gives you a remainder 1/4. So for this one, like after long division, like then you know that it has a oblique asymptote. This one oblique asymptote, like it has an oblique asymptote at half x plus 3/4. Half x plus 3/4. So the slanted asymptote look like this. This is actually 3/4. It also has asymptote at 3 over 2. This is 3 over 2. Now, for this function, if you put x at 0, to find the y-intercept, you put x at 0, you get 2/3. That tells you that the curve will cut somewhere here. 2/3. Okay, 2/3. Where is 2/3, you know? 2/3. Okay, this is 3/4. 3/4, and compare with 2/3. 2/3 is actually okay. 2/3 is actually below 3/4, no? So I'm going to squeeze it somewhere here, no? I'm going to squeeze it somewhere here, somewhere here. So this graph is going to look something like that. No? It's going to look something like this. Like that. You can actually more or less verify this using the GDC. So from the sketch of this graph, I will know that there's going to be a vertical asymptote at 302. In fact, even I do not sketch a graph, you probably can tell that it's going to have a vertical asymptote at 302, no? At x equals 302. So now to do such a question, right? To do such a question, with the graph, you therefore can tell that you can tell that actually the function between 0 and 3/4. Where is 0 and 3/4? This is 0. And 3/4 is somewhere here. Okay. So which means if you were to zoom into just 0 and 3/4, 0 and 3/4, right, the graph will look something else, no? When it's 0, it is 2/3. So it's here. And then when it's 4/3, right, 4/3. Okay, 4/3 lah. I think the graph looks something like this. I suspect. Based on my sketch, right, I think the graph looks something like this. I'm not sure whether or not these two are of the same height, you know. I'm not sure. So maybe to be on the safe side, I'm going to draw this one higher. I think the graph looks something like this. Okay. Just between 0 and 4/3. 8, 9. Okay, just be sure. Let me just think for a moment first. Times 2, 6, 8, times 3, 9. Okay. So I think the graph looks like this. No? So for this function, right, based on a small sketch, right, based on a small sketch, I therefore can tell that this function is actually a continuous. Okay, so this function is continuous, right? Okay, let me erase all this first. Okay. Okay, now we say, okay, function f okay, f is continuous on this interval. Right? And by EVT, f has an absolute minimum and an absolute maximum. Okay. All right. Now we want to find the absolute minimum and absolute maximum. As I told you, you are expected to actually find the value of the function fx, right, at the endpoints and later on at the critical points. So at the endpoints, right, at the endpoints when x is 0, it is 2/3. At the endpoint when x is 4/3, okay. Let me get a calculator. Wait lah. Minus 4/3. Minus 4/3. I'm going to calculate using the calculator again. I just want to be sure. Okay, 16.
Mấy cái sọc như vậy
by 2 times 4/3 minus 3. Okay, I get 2/3. I get 2/3. Check whether or not you get 2/3. No? So let me say, actually this graph just now. So it means this graph look like this. Okay, this graph like this. Then the next thing is you need to find the turning points. Okay, I'm going to actually use a calculator. Just a moment. I'll take my GC. I'm going to use my GDC to get because actually I can do it by hand, just that right. We can use technology to make our life easier. So what I'm going to do is on my end, I'm turning on the GDC. I'm going to actually use the graphical mode. I should use it right from the start, isn't it? Okay, I did not anticipate such a tedious calculation. Okay, -2. Okay, let me see. -2, and then divided by 2x minus 3. Okay. So what I've done is I'm keyed to the GDC in the graphical mode, and then using like GDC, I'm going to find the turning point. The turning point is 2, 2, no? So the turning point is at x equals 2. When x is 2, apparently from the calculator it's also 2, no? Okay, right. So since the function is continuous on the closed interval, EVT assure us that it has an absolute max and a absolute mean. Okay, absolute max and absolute mean. So based on this table, okay, so let's say from the table, absolute max equals to 2 and absolute mean is equals to 2/3. Okay, that is number 12. Earlier on, I was trying to do it all by hand, but I think that it takes up too much time. So over here, I showed you how I managed to actually sketch this curve using the calculator. I mean, using by hand, by hand. What did you say again?
Yeah, miss. Two is not in the range. Martin mentioned two is not in the range.
Wait. I think I counted the wrong thing. Sorry. Let me. Okay, this is wrong. Okay. Thank you. I went to calculate. Should be calculating the maximum point. Sorry. Thank you for pointing out. Okay.
Thank you for that one, not me.
Sorry. Let me calculate. Okay. Yeah, silly. Okay. I should find the maximum point. Okay. Okay. I think got 1-1. I think got 1-1. I think this point. Thank you for pointing out my foolishness. This point is actually 1-1. So there's 1 and 1. So the absolute maximum is not 2 but 1. Okay, so for those who have done, okay, do you get also 1-1 for the maximum point?
Yeah.
Okay, it's 1-1. It's 1-1, okay? So that's how we conclude, that the absolute maximum is 1. Any things to raise? Anybody? Okay, Kenneth, any question raised by them?
No.
No, okay.
No, not that I can see.
Okay, let's move on. For question 13 and 14, okay? Okay, are you ready? You all have the question paper, right? So you all can refer to the question paper. So I thought I want to write out nicely for question 13. Okay, I'm going to start with a blank page. We are all looking at the question paper, no? Question 13. Okay, question 13. Yeah, given this one, given this condition, given this 1 minus x squared gx okay, and then the x is within this interval. Okay, so the question right now is g continuous at x equals 0? So the question is g continuous at x equals to 0? Okay, like those other occasion, the first thing we need to do is we want to find out g0. How do you find g0? All you do is you put x into the inequality given to you, and you get 1 minus 0 square g0 right. So this g0, we all know that cos 0 is 1, so it becomes 1 square. So this implies that g0 is equals to 1 is therefore well defined. Okay, step 2, we are trying to find the limit as x goes towards 0 of gx. So to do this right, we say since limit x goes towards 0 of 1 minus x squared is equals to 1, and limit x goes with 0 of cosine square x is so equals to 1. Therefore, by the squeeze theorem, limit x goes with 0 of gx therefore is equals to 1. Then step 3, you state that limit as x goes with 0 of gx is 1 is equals to g0. Okay, therefore by 1, 2, and 3, g is continuous at x equals to 0, and that's number 13. Okay, so 13, I don't know why is labeled as challenging. I think it's easier than number 7, no? So maybe number 7 should be under challenging.
What's question 7 again?
Now you're done with 13, right? Okay, you want to embark into 14.
So true.
Okay, that's 13, huh? Okay, let's do 14. Okay, I'm going to turn on to a new page. 14. Okay, in question 14, okay, someone texted. Is it, did you text me? Someone text me? Okay, okay, sorry, not your class. Okay, question 14, 14. Question 14, you're given a function. The given function f is continuous on the closed interval 0 and 1. And then, what else? You're told that this function is between 0 and 1 for okay. So now part A, right? Part A, you're trying to establish the result that there exists a C such that f of C is equals to C. So the question suggested, no, let define a function, let gx. Okay, wait. I think I'm retract. I think I'll do this, okay? Okay, so to prove the result, I'm going to do it in few cases, okay? Let me do case 1. Case 1. Okay, case 1. If f of 0 equals to 0, we are done. Right now, if f0 equals 0, we are done. Agreed? Then you'll do a case 2. If f of 1 equals to 1, we are also done. Right. Now we need a case 3. Or case 3b. The case 3 will be the case where this is not 0. Okay. Now let us define the function. By the way, is Tingwei sleeping or not?
Is Bo sleeping? Bo? Bo is sleeping?
She's not, that's good.
Bo? Bo? The only thing where I know is from last year. Why? Yeah, sure.
Okay, so we want to establish that G is first and foremost continuous on a closed interval because the function f is also. This function x, right, is like polynomial. It will certainly be continuous. Then after you have established this, now you can calculate this number, okay? Oops. Okay.
What happened?
Let's calculate G of 0. What is G of 0 equals to? Is f0 minus 0. So it's equals to f of 0. And because of this condition, right? Because of the condition and the fact that fx is between 0 and 1, so therefore this one must be more than 0. Okay, so G0 is more than 0. Then let's calculate G of 1. G of 1 is f of 1 minus 1. And what you notice about G of 1 is okay, now this is not 1, right? This is not 1, and because it's not 1 and the fact that fx is between 0 and 1, that means this number here, right? This number here is lesser than 1, right? So I'm saying that this condition means that f of 1 is lesser than 1. So what I'm to point to you is this number here, right? This number here, right, is actually lesser than 1. So therefore this is less than 0. Since f of 1 is lesser than 1. Okay? Then so finally now I can use a IVT now. By IVT there exists a C between 0 and 1 such that G of C is equals to 0. Why 0? No? Because this number 0 because this number 0, right? This number 0, right, is sandwiched between something positive and something negative. You know what I mean? That's why I can say therefore there is a C such that GC equals to 0, and this in turn implies that f of C minus C is equal to 0, and therefore what you have here is f of C is now equals to C. So this question needs to be done in 3 cases now, right? Of course there are variations that people might have produced, but to be very comprehensive you potentially have to do it like this now. Okay, so we are dealt with the 3 cases of case A. That's 14A. Any question to raise? Okay, then allow me to do 14B soon. Let's pause for another 30 seconds for you to digest. Raise question if you have, no, when the thing out here. Oops. Okay, so let's do question 14. 14b. Okay, 14b is something similar, right? Something similar. So you want to start off like this, no? Okay, define a function gx as this. 2x f of x minus 1 plus x. And say that g is continuous on 0, 1 since f is okay, so the continuity is established. Okay, if you want to be very elaborate, right, you can say that this is continuous and times a polynomial which is continuous, therefore this whole thing is continuous. And then you can say that if this whole thing is continuous and 1 minus and then minus 1 plus x is polynomial, is also continuous, so the sum is also continuous. You can go and do it very elaborately now. You can elaborate a lot, but I think good enough to say that is now. Okay, because the rest I just assume that you know, you see. I was too much to write. So for this question, let's consider first case. Case 1. If g1 is equals to 0. Okay, if g of 1 is equals to 0. If g of 1 is equal to 0, then what we have here is 2 times 1 f of 1 minus 1 plus 1 is equals to 0. That means f of 1 is equals to 1 minus 1 over 2 times 1, and then we are done. Right? If you have a f1 that is like that, we have already established that it is what the question intends. Okay. Now on to case 2. Case 2. Case 2. Okay, if g1 is not 0. Okay, if g1 is not 0, let's do some calculation. Let's calculate g0 first. G0 will be what? Bear in mind what is g, no? G is 2x f of x minus 1 plus 0, and this gives you minus 1, which is less than 0. Why minus 1? No, because this whole thing will be 0, see? Because there's a 0 here. Let's calculate g of 1. G of 1 will be 2 times 1 f of 1 minus 1 plus 1, and this is equals to 2 f of 1, right? And then we are told that f of fx, right? We are told in the question, right, the function fx ranges between 0 and 1, right? Remember? Okay. So over here, right? If we have g1 is equals to 2f1, we want to conclude that this is positive. How do we conclude this positive? No, because when f1, okay, when f1 is 0, right? If f1 is 0, right? F1 is 0, right? If f1 is 0, then g1 is 0, no? Okay, let's see how. Okay, you now look at this expression here. Okay, if f1 is 0, you put all the x as 1, you will have g0 g1 equals 0, and that is actually our case 1. You know what I mean? So therefore, although f is between 0 and 1 inclusively, for this case 2, right, there isn't an equal sign for 0. So therefore, I can conclude that f1 is positive. Therefore, g1 is also positive. So then by IVT, there exists C in this interval 0 to 1 such that g of C is equals to 0, and then this becomes what? What's our gx? 2c f of C minus 1 plus C is equals to 0, and this again give me f of C is equals to 1 minus C over 2C. And then by this case, on case 2, we are done with the proof. Okay. Anybody has question raised? 14? So for this question 14, I understand that some of you actually had a little bit of issues. So question 14 requires you to come up with your own definition of the function, right? So how do I zoom to this now? Okay, I make some attempt, and if you define a gx with 1 minus C over 2C, right? FC minus 1 minus C over 2C, it might be harder to manage, you know. So I decided to use this one. It's just after some attempt. Then you may ask me, you know, how come I know that I got consider case 1, you know? Just because I find that in trying to do this question right away, I found that I was actually stuck here at first, because I will end up with this statement. I can't conclude conclusively that this is more than 0. So I realized that because of this, I need to consider a separate case, and that's why I created case 1, you know. So although you may see that I do it so smoothly, actually there are some trial and error involved, and I realized that actually I can't have just case 2. I need a case 1. That's how case 1 came about. Likewise for the other question, you know, the other one that we did for the 14a, right? How do I know like I use case 1, case 2, and then case 3? No, it's because I experimented with case 3. I realized that somewhere to make a conclusion, it doesn't work, you see. That's why I know that I can consider it separately, right? Okay. Okay, so if you have no question to raise, if you have no question raised, right, we are going to start off with our tutorial. I mean, not tutorial, assignment. Chapter 1, nothing raised, right? So we can start with the assignment, you know. I just tested your assignment, you know. It's all in the class WhatsApp. Are you able to see the assignment? Okay. Let's take a look at the assignment question. We can actually do some discussion, you know. Let me open up the file, okay? Huh?
Huh?
I can't hear you.
Yeah?
Okay, shall we now embark on the assignment? I just tested your line, I just tested your. Okay. Okay. There are 3 questions, so maybe we want to actually give yourself. Okay, can anybody now start off with question 1A and 1B line? 1A and 1B. You give yourself that 4 minutes to try, and then at the 3:20 we'll go through together. Okay, try 1A first. Okay, so because I just give up to you, so I can give some time right now to try. So everyone please try, Kenneth, you want to alert everyone to start trying the assignment question right now, 1A and 1B.
I think everyone is very much alerted.
Oh, okay, that's nice. That's very good.
It's in WhatsApp. It's in WhatsApp. It's in WhatsApp. For those who don't know, it's in WhatsApp. Or if you can't find it, look at the board. Just look at the board. Is there a way to freeze it?
Then I scroll the bottom.
Write neatly, write your assignment on a proper A4 paper, whether foolscap or white paper. Make sure it's neat and big. Use big handwriting,
Aiden. Big handwriting. Good question.
3 more.
Oh, for this one, yesterday.
Yeah.
Good, thank you. The mic is on. The mic is on.
The mic is on. Assignment are to be handed in, actually. Yeah. So please write neatly, clearly, and bigly, because I want to check your work, you all already know, right? Assignment is no longer part of the graded assessment. Nevertheless, you still want to do your best, produce the best piece of work, And in the class WhatsApp today, I've also given you the dates of all the graded assessment, the graded task dates. Someone asked me for it before. I just forgotten who. You are? Okay.
I was the one who asked it.
Kind of. A reminder, next Friday is our grade task 1. Right, next Friday. Please bear in mind, so while you celebrate your Chinese New Year, you also want to remember, that there is actually grade task 1 next week. Tomorrow, when I see your class, we will actually do chapter 2.
Tomorrow we don't have math. It's day after tomorrow.
Oh, so left with Thursday.
In fact, we actually even have class on Friday.
We have class on Friday, right?
Yeah, we have.
Celebration Chinese New Year is after 10 o'clock, right?
Yeah.
Oh, so we're lucky. We didn't miss anything.
After 10:30.
After 10:30, right? Okay, that's so good.
Is it until 9:30 or 10:30?
Doesn't matter. Our class ends at 9:30. Just nice.
9:30, yeah. No, doesn't mean we get to skip PE.
Oh, you get to speak.
No, PE is 9:30 to 10:30.
Oh, that's okay.
That's Friday.
Friday. Oh.
Because we can give the excuse that we are wearing ethnic clothes.
Okay. Let's go through our first question in the assignment. Okay. Number 1, A. Limit x goes towards -3. X plus square of 6 minus x over okay, so for 1A, right, you can choose to hand in to me assignment in soft copy, you know. I'm actually okay, you know. Let me check something first. 9 plus, okay. Okay, then for the numerator, what is it again? Okay, so for numerator, we can then factorize it into x minus 3 and x plus 1. Say.
Is there x plus 3, x minus 2 for the numerator?
Numerator.
Yeah.
Numerator.
The numerator is x squared plus x minus 6. Because of the bracket there.
Okay, so it's a plus and a minus, right?
Minus 2, it's minus 2.
Yep, minus 2. Yeah, what do you see just now?
Curtis comment 3 times 1 is not 6.
Okay, the medicine caused me to think strangely.
Probably should have math lesson.
Yeah. Medication, you see. So I'm excused. And then this is gonna be x minus 6 minus x. Okay. Then of course, you can have cancellation here and here. So now you bring x is minus 3, you get minus 5 over minus 10 minus 3 minus 3. So you can get 1 over 12 minus 12. Okay. So that's 1A. So you must write like this, no, neatly, you know, show proper steps and working. Okay, now let us embark on 1B. Okay, 1b, you have limit x goes towards root 2 square 2 x cubed minus 4 over x squared minus 2. Okay. So for this question, the denominator can be factorized. And then this can also be factorized now. Okay. Well, this b root 2 x squared minus root 2 will be plus 2 root 2 2x squared plus 2x. Okay, you want to check my factorization? I could be wrong. And then once again, you can cancel off. And then this gives you, check my calculation again in case I'm wrong, like just now, do point to me, you know, because I'm doing together with you all for the first time. Okay. Then this gives you 2, 3, 4, 5, 6. 6 over 2, 3. Check for me. Did you get 3? Yeah. Check no. My arithmetic once again, you know. So I check 2,
Yeah,
3, 4,
I got 3.
3. Okay, so there's actually 1b. Okay, give yourself that 5 minutes to try number 2. Then we go through number 2 together. Okay, give yourself 5 minutes. As you're trying this number 2, right? I have asked students to sign up for some of the science fairs. 504, I'm sure some of you have projects to bring along to a science fair. You want to sign up, you know. There are 2 science fairs. There are 2 science fairs. One is the ASRJC science fair. And the other is the Australian one. Okay, for this question, right? For this question, first and foremost, we want to calculate limit of x going towards 0 of sine so to calculate the first one, what you do is you can put in a 2 right, and then this gives you right. On the other hand, the right hand side is actually a constant function. This is just 2, no change. So by squeeze theorem, the limit is equals to 2. But what the question wants to find is actually the limit of function fx. Then you can say that from here, right, from here, limit x goes to 0, because both limit exist, okay? Both limit exist. I can write this as like that, provided the denominator does not go to 0, see? Right? So therefore, and this gives you 2 times pi times cos 0, which is equals to 2 pi. Okay, that's question 2. Okay, that's question 2. Okay, give yourself 5 minutes, then we do question 3 together.
Differentiation again chapter 2. We are learning what is differentiation.
Okay, please spend a bit of time for question 3, then go through together. Maybe it's good to put a condition statement here, since both limit exist. And denominator, right? Okay, let's move on to question 3. Question 3, yeah. Okay. Question 3, part 1. It asks you for the limit as x tends towards 0 plus of gx. And then this gives you limit x goes towards 0 plus of this function. Okay, because you're approaching x from the 0 plus, means approaching 0 from the positive 0, from positive value of from positive values, right, on the right side of 0, I can then rewrite this thing as like that. And now this becomes okay. Then what do you do from here? We actually multiply by the conjugate. For the numerator, right? After all the expansion tidying up, you have x. And obviously, this x and this x can cancel off. You're left with 1 over 2. That's the 3 part 1. Now, how do you do 3 part 2? To do 3 part 2, to answer the continuity question again, right? We again have to look for the limit. In the part 2, you now have to work out the limit. Right? As x approaches 0 from the left. Okay, can you all try? So this becomes limit the change is on the denominator. I want you to note this difference between the two of them. Here, Okay, there's a difference between the earlier one, right? And then this gives you in this case we do the same thing. Okay. And it gives you minus
Is it mine or his?
it's mine, it's mine. Mine is mine.
Okay.
Sorry about it. Yeah, just ignore it. Just ignore it. No.
I thought it was mine.
And this one is just ignore because office lah. I can't shut them off. Okay, so because the right hand limit, right, and the left hand limit, in this case, the left hand limit is even worse. It doesn't exist, no. So your conclusion is since limit as x goes to 0 of gx, right? Okay, so from office I just ignore it. Okay, it does not exist. Therefore, g is not continuous. Oh gosh. Okay.